Hello everybody. So someone asked me about my dots and boxes program and asked me a bit about how it worked. One thing that throws some people off is how the whole import class works and how the math that converts from lines to box ID and from box ID to lines, how that works and why it works as it does. So one of the things that throws some people off is that I have these small things here that say if line to test is horizontal, we will get box ID 1 and 2 like this, but if it's not, we'll get it like this. Now the reason for that I will explain in a bit, but that's one of the things that throw people off. Other is what we actually use that for. So one thing that's important to note is that I store my information as a vector of integers for each box. It's an integer because players can have set it on, either player 1 or player 2, or it could be off or not marked at all. That would be a 0 in this case. And then we have vectors with booleans. We have one for vertical lines and one for horizontal lines. Now these are only booleans because all we need to know is have this line be marked or not. So why do I put them into two different booleans instead of just one vector of booleans? Well, let's look at it. Now, if you have the game dots and boxes, what you know is that you have a set of dots. In this case, we have 6 by 6 dots. And those 6 by 6 dots creates the possibility of 5 by 5 boxes being made by connecting lines at the dots. Now this also means that you will have 5 by 6 horizontal lines between them, but you will have 6 by 5 vertical lines because of the fact that you do not need a horizontal line going outside here, and you don't need a vertical line going down here to create all the boxes of the game. This is why they are stored in each their vector, because the math to calculate which line we were talking about, if you should jump every second, is even more complicated than the math we already have. So each line, each box has its own ID in its own vector. The ID is also the index where you can find it in that vector. To calculate that, you take the coordinate of the dot that the line goes out from. That's for these two lines, and this box, it's this dot, and so on and so on. Then you take, for instance, in this case, we have the x4, y2 coordinate. So if we want to calculate the horizontal, we will take the y coordinate and multiply it by the number of dots minus 1, in this case 5, so we'll get 10. And then we'll add the x coordinate. So we add the x coordinate to get horizontals. We do the same with the box, as you can see right here. Now for the vertical lines, we instead take the x coordinate and multiply that with dots minus 1, 5 in this case, so that would be 20. And then we add the y coordinate to get 22. Now for the let's test it with the box. So we take 2 times 5, 10 plus 4, 14. And we know we count at 0 first. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And as you can see, 4 by 2 is right here. That is how I calculate the ID of each and every single object in this screen. This is also what you will see going back and forth when you hit, for instance, this line here. We know what line it is, but we will store the coordinates to 1, and we will use those coordinates to calculate the two boxes on top and below. That's also why we have another way to calculate if we have a vertical line, because we don't calculate top and bottom, we calculate the right and the left box instead. So that's a bit about the math, and that should make the whole class a lot more easy to follow. So we also have this struct, it's called line ID. This we use to communicate between our functions. It stores the ID of the line we're talking about. If we later need to mark it, it stores the coordinates if we need to check boxes around it. And it stores an information that says, is this a horizontal line? If it's not, then it's vertical. Has this line always, is this line hovered above? and has this line been marked? These are the informations that we need in this case. Talked about the vectors. Then we have the board itself. We need to be able to set the board up, and we simply do this by going through the dots horizontally and vertically. And if we are not at the very edge of the dot, we will add a horizontal line. In the same way, if we are not at the very bottom, we will add a vertical line. Now, if we are not at the very horizontal end and we are not at the very bottom at the same time, we will also add a box. Now, before we do this, we also have a clear function. This function will be called if we have already played the game and then want to play it again. We start by setting everything to 0 so we don't overload the vectors. Add to the end of the vectors, that would make it very hard to find the items. We also have some getters, not that much of them. Then we have this getLineHit function here. Now all this function does, it is calculating where is the mouse, and is the mouse above one of the lines. If the line is horizontal, then it needs to see if the X and Y position of the mouse is within this bounding box. And if it's vertical, it will look at this bounding box. And it just returns true if that's the case, or false if none of them. It's just to see, does the mouse hover over a line. Now let's go down a bit here. Now, each time the player updates the M class, it gets all this information where we are. It also knows if the player have pressed the mouse. Now, the first thing we do is we have this stored function where we take the informations to use later. I was just a bit confused here now. So the first thing we say is, okay, check out, is the line being hit right now? Are we hovering above it? Now, if that's the case, then we'll say, okay, is the line marked? If the line is marked, we will color it red, because we should not be able to mark it. And then we will return false. If it's not already marked, then we will color it this, and if we're pressing it, we will color it this color, and then we'll actually set the line to being pressed. It's pretty important to store this information, and we will return true. If we are just above it and we're not pressing it and it's not marked, then it will be green to show that we could. If we are not hovering above it, it will be white if it's already marked, or it will be black if not. This is pretty important here. Now, if we actually do choose to press the line, and we are allowed to press the line, we will go in and see, okay, so does this pressing of the box make, of the line make a box? So we'll tell it what line we're talking about, we'll tell what player is currently pressing, and we'll tell how many boxes that are left in the system. How many boxes player 1 and player 2 has of points. So, going to the make box here. What it does is it makes 2 integers for box IDs. As I told before, if we have a horizontal line, we need to be able to check the box above and below. And if we have a vertical line, we need to be able to check the box on the right and the left side. Which is what it says here. Okay, so if we have a horizontal line, a horizontal line, then our first box ID we need to check would be calculated like this, and the second would be calculated like this. While if it's a vertical line, we will calculate it like this. And it's very simple just to say right, left, or top, bottom. That's what it does. Now, after it's done this, it will go in and say, okay, so are we somewhere in the middle of the board? That is, are we not touching an edge box? Then we will check both box 1 and box 2. And if the make a box or is enclosed, we'll give the player a point. But if we are at the top of the system, then we will, at an edge of the system, we will only check one box. the appropriate box, depending on if we are on top, bottom, or right, left. Now, if we have actually gained some points here, we will return true, that is, the player got a point, so there's no reason to go back. While if not, then we'll just return false, and the system will change player. Yeah, and here's the adding of the points. So the isEnclosed system here simply just gets the ID of the box that we have sent. And from that ID, it will calculate the x and y coordinates of the box. I could have stored that in a struct, but I decided to just calculate it quickly. That's what we do here. Actually, we simply say, okay, so we have the box ID, for instance, it could be 14 like before, and then we will say that as long as that is greater than the amount of dots that are in a line, then we will remove that amount, and we will know that, okay, we are 1 y longer down. When it's suddenly no longer higher, then we know, okay, then this here will be the total y coordinates, and count will now be the x coordinate. I stored here simply just for readability for myself. This way we can calculate, okay, so all the lines that are touching the box we're talking about will be this line, this line, this line, and this line. That will be the ID of those lines. And then we'll simply just check, okay, so are all these 4 lines currently marked? Remember, the player has just marked a line, and that is one of these 4. So if that's the case, if all 4 are marked, then we return true, we have enclosed the box. If not, we will return false. And that is basically how the whole class system here works. Now, aside from that, we also have the program itself, how the program runs here. But that's basically just normal game architecture. We of course have our stages here that the system runs through. So whenever the game starts up, it will just set our random, because I like to use random for different stuff. In this case, I use it to choose what's player start. Then we will go in and say, okay, if we are at the start of the system, we should use the setup game function. And the setup game function will return true as soon as the player has chosen what size of board he wants to do. When that is done, it will set up the board to be the size it should be. And then we'll change the stage to play. Then we'll go into the play stage, and as if run game returns true at any point, that means, okay, now we have completed the game, and we will go to the score system. And when we are done with the score system, it will go back to start. Unless at some point the play stage is exit. In that case, we will return false, and that will exit the whole engine. We have the show score here. It simply just calculates how many boxes each player got and displays that and what player won. We have the setup game. It clears the screen first, and then it shows a line that says choose the board size you wish and the different board possibilities. It prompts you to press the up or down key and space, and going up and down will move a rectangle that we draw right here and fill right here. That is basically all that it does. And whenever you press enter, it will remember how many dots you have chosen the system should be. The run game itself takes the coordinates and the mouse current action and stores that. It clears the screen. It sets our pixel mode to normal because we have no transparency that we need to use here at all. It gets the board size for later use. It sets a pixel color here. That's because I use this whenever I color stuff down through the system. And it then starts to run through each and every single x and y coordinate. It will it will then ask each and every single line to be drawn, and when it's drawn, it will also ask the different questions of how it's going with it.